Yo everyone, has the stream started?
I think it goes up to like 104.
Has the stream even started? Let me check. Okay. Why hasn't this stuff loaded? Yo everyone. Yo everyone, how is it going? Uh Hi ladies and gentlemen, my name is Alter and this is a really chill stream. Chat rate. It's just a chill stream today. I don't really want to do any studying today. I probably would do some. Let's see what happens. Basically, I'm watching LGT right now. Let's watch together.
105 on a normal card. You just max that out, and you can play with voltage a little bit. And then I just do 25 megahertz at a time on the clock and run it. And if it passes, go higher.
Easy enough.
Easy. The voltage is tricky on 5090. It gives you a percentage.
What does that mean?
I just put it at 100%.
Okay.
All the volts.
100% voltage, sure.
And you can see that doesn't really affect much. It caps itself out. They don't really want you to increase voltage on the card when power limit is. So we're kind of controlling the power only through power target. So you can use VF curve to lower voltage, but the performance is worse. I just avoid messing with voltages and just play with power target and your core clock.
So if it becomes unstable when you go a tiny bit higher on the boost, you increase the power until you max it out?
Yeah, so say I have increased the GPU boost clock by 200 megahertz, and this failed. So you could try like 95% power target and see if you pass. And if you pass, that's about all you get.
Would you ever turn down the power target and try again and see if it was a thermal issue?
You could turn down power target, but then it's just going to take away your clock because you'll hit the power target.
Because Jake says he...
Linus is like, Linus is taller than me, but damn, he's surrounded by a lot of tall people. I think he's shorter than the average height in Canada.
backed off voltage, and that was how he beat us yesterday.
We run the air conditioner, so we would by the end of the run, the card was really warm. Whereas here we're taking the heat away and it's not really going up after we started the bench.
I see.
So by the end of the bench, we were failing maybe in the last 2 seconds.
Are they gonna get it into the top
I got
10?
1.3 degrees for your chili ready.
Likely.
Did you have kind of a thought on exactly how we're plumbing this up? I was going to close these and then just remove a couple of PCIe brackets, throw them with the back. Oh, okay, then you just go in the back, or they could just go here and store it there too. I don't think we need the reservoir in the loop either. I was just going to plumb around it. I was basically just going to go like here.
Oh yeah, we can just totally delete the whole radiator if you want.
We need a radiator for it. Radiator for chumps.
Yeah, we've got a much bigger one.
Hey, there's just...
Mate. Why is... Either there's always some form of... Let me check, wait a second. Opening the stream. Content. Dashboard. Where is my live? I think I need to go to the home page first. We're in the bloody world. Why isn't the live working today? Some form of... Let me just... Okay. Where is... it's alive.
Display for coolant temperature in there. Is that what that is? Yeah. Oh, sick. Does it go sub-zero?
We don't know yet.
Oh, neat. Okay, we'll find out. Cool. The last thing that I want to do is drain this reservoir because we know when we put this in a sub-zero chamber and it freezes, it will break. It's about to get real, Alex.
Oh, Jesus.
Right, there you go. See, that's the fastest way to drain a thing.
This is really nice how Leon Lee did this. You just push on that. Whole thing comes out.
Buddy, that's awesome. It's full of water, don't forget.
Yo, man.
Okay, we'll find out. Cool. The last thing that I want to do is drain this reservoir because we know when we put this in a sub-zero chamber and it freezes, it will break. It's about to get real, Alex.
Oh, Jesus.
Right, there you go. See, that's the fastest way to drain a thing.
This is really nice how Leon Lee did this. You just push on that. Whole thing comes out.
Buddy.
Yo, there's always some form of fault, la man. Yo, man.
Okay, we'll find out. Cool. The last thing that I want to do is drain this reservoir because we know when we put this in a sub-zero chamber and it freezes, it will break. It's about to get real, Alex.
Oh, Jesus.
Right, there you go. See, that's the fastest way to drain a thing.
Yo, man.
Okay, we'll find out. Cool. The last thing that I want to do is drain this reservoir because we know when we put this in a sub-zero chamber and it freezes, it will break. It's about
I
to get
guess
real,
now
Alex.
it's working.
Right, there you go. See, that's the fastest way to drain a thing. Yeah, cool. Okay, I'm just making sure you know before you, spill water. I'd hate for any of that to happen on the shoot. It's been a really tidy, clean shoot with my spilled water so far. Right, there it goes. Professionals. All right, let's fire up the chiller. All right, let's go. For any of that to happen on the shoot. It's been a really tidy, clean shoot with my spilled water so far. Right, there it goes. Professionals. All right, let's fire up the chiller. All right.
Now the stream's working. Okay.
She stopped pumping. I'm just gonna give her the old power cycle here. Also, that poor pump sounds like it is dying. She moved a little bit of coolant, and then she stopped. That seems to be full of coolant.
Yeah, we can try again.
Okay, we're just trying again. Not gonna lie, a little scared. That sounds.
What the hell, man?
Shouldn't have to.
No, we shouldn't have to, but we might want to do it. That is super weird. Why? What are you adjusting? Oh, this is the pressure.
Oh, Jesus! I got shrapnel.
I was going to say we should put some hose clamps on those, and then I totally forgot. I brought them over.
Oh my god, it's a mess. Do you guys are toxic? That's all over me.
Probably not great for my pants, that's for sure. I'm supposed to cool the computer, Alex, not the people.
Look at the screen.
Oh no.
And this video had so many fun moments that we couldn't fit them all in this video, so the extras are all on Floatplane. Go check it out.
Oh, he doesn't see me, he doesn't see me. No. Come on! First you call me small balls, then you say you don't believe in my ability to install a water block. Alex, were we reading it wrong?
Yeah, we're just really dumb.
Oh, this is peak cinema. Fortunately, the glass panel in the front of this computer took the brunt of it. I don't think we hit the GPU or motherboard. One drop right there. We hear our screen in the back, but I think she's pretty clean. Okay, so she was clearly moving it.
Yep.
So,
That was awesome.
Airlock.
is there a valve shut off somewhere else? Because it seemed like it was pushing against... Yeah, because that's the out. Oh man, dude, I am super confused. Oh my god, I figured it out!
Oh, we're idiots.
The shut off! We had the valve closed on the CPU block. We're lucky we didn't blow up that GPU block.
That would have been fine. We know they're good for over 200 psi.
That's true, we do. Well, not that one
This
specifically.
pump only does like 100 psi.
Our Canadian healthcare doesn't cover your chemical burn, I'm sorry. Okay,
Yeah, I probably have better coverage here than I do at home.
let's do this thing. You ready? Oh my god.
Who's ever in chat can he or she type something?
All right, we did it.
Is there overclocking always this exciting?
Not as explosive as this usually.
What do we think is safe to set the chiller at? Right now it's at 23.
Yeah, lower. I bet we could do like probably 12 or so.
Yeah, I was gonna say 12.
All right, give her a sec. She's chilling. She's just chilling, you know? Jumping right into a benchmark already. I think we're, 5 degrees cooler than we were when we were relying on ambient air cooler loop down?
Exactly.
And did you change any settings or anything, or are we just hoping it's going to...
More clocks.
Okay, we're still on 1,000 watt BIOS, hey?
Yeah.
And we're at 43 degrees?
Yeah.
Wow, so it was really heating up that water before.
Well, I think the bigger thing now is that the pump just is ripping compared to 35.
43, 810.
There we go.
All right.
Whoa, buddy. Okay, let's submit that, buddy.
OTT right here.
Let's go number 17. Look at that, Jake. Honestly, though, Alex, she's struggling to pull down.
Yeah, what's on the go?
Well, 1,000 watts of GPU.
Oh, that is a thing.
Like, does this not have 1,000 watts of capacity?
It has 5,000 watts.
Oh, well, on the one hand, we're pretty upset about our industrial chiller not working. We think maybe there's been a gas leak of some sort because she's pulling down, the compressor's running, but the condenser's not hot, and it's not pulling down to the temperature quickly, and it's actually going up while we run our benchmark. The good news is that we just hit 44,000, so is that still 17th place?
16th.
Oh, wait, we took your own spot. Normally, I'd be thinking, okay, we'll just get an HVAC technician to come out and fix our system, but the problem is that Alan's got a flight to catch. So if we want to go very, very sub-zero, we're going to have to come up with some ideas. Hey, look, I found an idea. Oh, yeah. Now that's a radiator. We throw this with a bunch of high-speed fans inside the environmental chamber, and we can chill the loop down that way.
Ooh, oh, that's pretty fast.
Spicy.
Even though the chiller isn't chilling quite as well as we hoped, the pump in it is still fantastic, and our scores just keep on going up.
I'm trying to find 3,000 RPM fans, but they're all mixed in together with the 2,000 RPM fans. Hello. Huh, yeah, that'll do nicely. Here's what I'm kind of vibing.
This
Huh?
time,
All right, I got a plan.
I think. They didn't.
What are you doing?
I'm making a shroud.
Why?
Because if we just put the fan against the radiator, we're gonna miss out on probably a solid 60% of the actual cooling capacity of that radiator. Dude, this is gonna be awesome. Heck yeah. Oh, dude, see this? This is what I'm talking about, okay? So we get the fan off of the fins. Boom. We're making use of all that airflow. Boom. Oh, I wish I'd censored it. Well, it's done now. So this is gonna be sketchy. Shield your virgin eyes.
That's killer.
All right, so now, theoretically, all the airflow will go through the radiator. We have a cooling solution. Side quest complete. You have obtained this friggin' thing. Okay, here we go, boys.
Oh my gosh, what the hell is that?
That,
Oh my god.
my friend, is a radiator and a fan. Whoa, buddy!
Oh, that's fast.
We're working over here.
I was working. What are you implying? I made this.
Beautiful.
Oh wait, did I ever get a pump? Okay, well I found a reservoir, so we have that.
Well, what I was thinking was we still use the chiller, even though it's not chilling too good. That pump in it is insane.
Okay.
So we put the chiller back
Are we gonna
there.
lose a lot of our cooling though?
Maybe?
Use the res pump thing we're using in here now.
Yeah, we could just use that one.
We can do that.
Yeah.
So wait, where does this put us? Oh dude, let's go! Let's go! We're top 10, baby! Let's go!
Been cold yet, right?
In terms of raw actual numbers, we're not even that far off some of these scores.
Yeah.
Do you think she's got more left to give?
I think she does.
All right, I'm excited. She's still cooling.
Wow, that is.
So I think she's gonna cool your GPU there. I think we're good. So we're just gonna use this, and we're just gonna set it up in there. Oh, she's chilly boy.
Why the hell is Linus's team making world records all of a sudden? First they made the world record of like. First they made the world record in which they calculate the most amount of what you say numbers of pi, and now they're making this world record. They're probably up to something. They're always up to something.
She's chilly. Close out here. I feel like we could do that. Okay, I'm gonna run the power out to Alex. All right, how are we feeling about this?
Mid.
We call that a Canadian W. Feeling mid. Okay, here we go. Wait, should we take the tempered glass off?
No, it's alright.
Okay. Oh yeah, bud. No problem, bud. Okay, so we got the radiator here. Love the 011 case. It's designed so you can reach right through it when you want to get to your janky sub-zero water cooling radiator in your environmental chamber like that. See, bud? She goes into the radiator, up the top of the radiator, down to the GPU. These are stoppered. Then we got this here. There's some tubing. And then if you want to give me like a cable tie or something, then we can come off it here. You never grow up. You just get better toys. Let's get some windshield guys. We don't have a funnel by any chance, do we?
Man, I really hope that this doesn't leak.
That's good. We're gonna need another bag, I think. All right, Alex, you want power cycle it? Dude, the coolant's at 16. And that's with the door open.
Reese, are you hitting the fan?
Yeah, go for it.
And this is how you set records, I guess.
Well, depends. We haven't gotten there yet. Hey, we got a great view of all the displays and everything. So our coolant is at 8 degrees and our GPU is at 12. That actually checks out. That sounds about right. That at idle, our GPU would be a few degrees above our coolant temperature. We're going to see that delta grow once we're actually running benchmarks and stuff, but this is a very good starting point. You know which delta I'm actually most impressed by, though?
Damn.
How close our coolant is to the chamber temperature.
Yeah, it is really close.
2 degrees off. That's how much air we're moving through that radiator. Fear it. How's them temps? You like them temps?
Nice,
temps?
nice.
Everything okay? We're at minus 0.5 and our loop's at 4 degrees Celsius. GPU sitting chilly at 6.
This works surprisingly well, given that our chiller stopped chilling.
I can't believe we pulled this solution out of our butts. Okay, so we're at 30C on our GPU right now. She's running pretty smooth right now, eh?
Yeah.
45, 349.
Ooh.
We're in 7th?
7th. That is a whole gigahertz over the base of like a Founders Edition.
And it didn't even take very much work, did it? Just for me.
Whoa, this is going to be a pretty nice run.
I think so. Yeah, we haven't even failed yet, really.
Oh, shouldn't have said anything.
Why did you say that?
Did you see that?
Why did you say that?
We've been finding that the 50 series is this really weird thing where when the load drops, like you're not hitting it 100%, the frequency just goes to the moon for some reason and then it crashes.
45, 354. That is a touch higher, isn't it?
5 points.
Yeah, okay. Hey, look, I'll take it.
So you don't think that giving a CPU anymore will get us any more score?
Probably not. Intel actually scores a lot higher on this 1400 series for some reason.
Oh.
Well,
If we would have used one, we probably won very slowly. Sorry.
This is what we get
Too
for
late.
building a computer that's actually for gaming instead of for getting higher benchmark scores.
Exactly.
Oh, that is fast.
Oh, 6. We're going for
Number
5.
6.
Let's go, baby.
Let's go top 5. Actually, we're the top AMD result now.
Top AMD.
Top Canadian.
Let's go.
All right, how much is this drawing? Oh, it's not too crazy. 900 watts at the moment.
Okay, 1,028.
Yeah, 1,000 and a bit. That's about what we expect. That's what we were doing before.
Here we go. I believe. We're just shy of minus 20 on the chamber. We don't want to go too much lower than that. Once you start hitting minus 30, things don't like you.
That's what like the juice and the capacitors of your power supply just starts turning into solid, not juice.
She's artifacting. Nah, she's artifacting.
Oh, that's a fun one.
Oh wow, we're starting to get some really weird reported numbers there. Well, our RAM's on the sun, so that's probably going to be a problem.
You ever feel like if you don't move, it'll pass?
Yeah.
No, she
Oh, I kind of almost just want to restart the computer and see if that helps it.
Okay.
Seems to be a bit confused.
I like it.
What makes this a Hail Mary run exactly?
I don't even know what I said, so we'll just see if it works. What do we need, like 50 points?
Something like that, yeah.
Ah, not much.
It's always the last 50.
We're at our full minus 25 now, so there's nothing more we're going to get from more cooling. We've kind of been changing multiple variables as we've gone here because we've been adding more cooling capacity as we've been tuning it, kind of building the train as it's flying down the rails.
Come on. Oh!
Whoa!
Is that enough, boys?
Whoa, now that's a Hail Mary if I've ever seen one. Is that her name, the astronaut?
Mary?
What, Katy Perry?
No, it's Mary. 45.
Fourth!
Number 4! We're top 5! Let's go! Let's go, Canada! Let's
called
go!
Damn, these are LN2 scores.
Really?
Yeah.
So we went faster than Ellen too.
Yeah, man.
Why were we able to beat an LN2 rig
Yeah.
with a processor that really is not as optimized for this benchmark? What did we do right? Right.
So
what do the people do?
They're using a D too. I think it's maybe slightly less performance.
Got it.
But I think the cards might shut off at like minus 40. So we're almost there, I guess, cooling wise.
Understood. That makes sense. So do you think if we had a 14,900 in here that we would have a shot at top 3 podium finish? That's 500 more points. That's a lot.
So I talked to SafeDisc and he said he tested it and it was about 1,000 more points. So we maybe would have been up top here. I'll go home and do that, okay?
Okay, I'll send you the chamber. Yeah. That's a nice card you got yourself there.
Not bad.
She seems pretty binned. It looks like you might have a shot at number 1 with that thing.
Are we happy with this?
I'm really happy.
Yeah, that was great.
Like, we're as high as we're going to get. We squeaked past Ralph. Squeaked past.
Really fast computer. Should we game on it?
It'd be kind of silly if we didn't.
What's the cost of the system plus the chiller?
That's not a bad title.
50K gaming PC?
Yeah, how fast is a $50,000 gaming PC? Never mind that most of it is not the PC. I can't believe we hit top 5. Let's go.
Never done it. We're getting ready to pack up.
That's why he's so big, because he's full of shit. Can I win Counter-Strike now? Oh, yeah,
There we go.
Oh, now we're going fast, boys. Got him. Look how fast that kill was. Damn it. Wait, our FPS isn't even that good. Oh, wait, we're at 1440p.
Yeah, she doesn't look out bad.
Let's go. Headshot. Boom. Damn it. Oh, how can I miss all 3 of those shots? And he ain't even a pro.
Maybe his computer's in a giant freezer too.
That's probably it. He probably out-freezered me. Ah, hopeless. God, I missed that. Come on.
Good movement. Good movement. All right.
Come on. No! I give up. Oblivion Remastered. Here we go, boys. Okay, we're running at a casual 560 frames per second.
Oh.
No. She's good.
No, I don't think it's good.
Oh, she's not good.
No.
She's not good. She's bad.
That's a wrap.
Rap, just like this segue.
Oh, you're gonna wrap.
To our sponsor.
Micro Center, rated number 1 in PC Mag's 2024 Reader's Choice Awards, it's clear that Micro Center is the place to shop for your next gaming or work setup. With close to 30 locations all over the US, they've been dishing out deals and providing excellent customer service, technical knowledge, and support for decades. Speaking of deals, from now until the end of May, they have deep discounts on over 150 desktop PCs, like this absolute baller gaming rig, or this space-saving all-in-one solution, both from HP. And residents of the Bay Area rejoice! Their new Santa Clara location is set to open anytime now. So use our links in the description to shop Micro Center's May desktop deals, and make sure you get your free flash drive when you check out their new Santa Clara location.
Huge thanks to Slave for coming out. Thank you for watching. If you guys are looking for another video to check out, how about that time Slave came and we got a CPU to a nice 6.9 gigahertz.
Should I just start coding? Well, there's nothing else I have to do, so no.
Quote unquote, x is less than y. So this isn't a very interesting program yet. I'm literally just stating the obvious based on the math, but it's allowing me to now introduce some new syntax. And exactly what is this syntax? Well, it's this. Not just the keyword if, which I've added here at the start of line 4, but then I ask my question here. X less than y. X is one variable on the left, y is one variable on the right, and of course the less than sign is expressing the mathematical question I have. What I've highlighted here is technically called a Boolean expression. A Boolean expression, named after a mathematician named Boole, is simply a question that has a yes or no answer, or technically a true or false answer. And that's nice because if there's only 2 possible answers, it's very easy for me and in turn the computer to make a decision. Do this or don't do this thing. Now notice if you come from other languages, you might notice that I have not typed any parentheses. They are not in fact necessary, at least in this case in Python, but I have typed a colon at the end of the line. And even more importantly, at the next line, I have begun my line with some indentation, hitting the spacebar 4 times or just hitting tab once, which will automatically be converted to the same. That indentation is what tells Python that line 5 should only be executed if the answer to line 4's question is in fact true. So if x is less than y, that phrase will be printed thereafter. Well, let's add a few more lines of code. How about another question? If x is greater than y, then let's go ahead and print that. X is greater than y. And let's do one final question. If x equals y, then wait a minute. What have I done wrong here, right? A good I here. I don't want to assign y to x. If x equals y is how I express equality. Let's go ahead and print out x is equal to y. So I now have 3 conditions, if you will. One question asking x less than y, one asking x greater than y, one asking x equals y. Let's run the code. Well, down here in my terminal window, I'm going to run python of compare.py and hit enter. What's x? Let's go with 1. What's y? Let's go with 2. This should, of course, execute that first line of code and tell me, indeed, that x is less than y, exactly as I would expect there. Well, what just happened, though, in code? Well, let's take a look perhaps at this same code visually, particularly if you're a more visual learner. This, I dare say, is what just happened. So what we're looking at here is a flowchart. It's a diagram of this program's logic, and more technically, it shows the program's control flow. That is the ability of you in code to control the flow of a program, generally from top to bottom. In fact, let me go ahead and zoom in on the top of this flowchart, and you'll see an oval at the very top that says quite literally start. That is, irrespective of what shape or layout the diagram is where your own thinking and logic should start when trying to wrap your mind around this program. Notice that there's an arrow from start to this diamond shape, and inside of that diamond is a question, a Boolean expression, x less than y. And this shape just means, based on the answer to that question, go left or go right. Specifically, go left if the answer is true, or go right if the answer is false. Well, the inputs I typed were 1 and 2 respectively for x and y, so of course 1 is less than 2, so that's why my program printed out, quote unquote, x is less than y. But recall the code. The code then proceeded to ask 2 more questions. Is x greater than y? Is x equal to y? Well, the flowchart depicts those questions too. Notice that no matter whether the question had an answer of true or false, the arrows both converge back down to this second diamond shape here. And that second diamond shape asks the second question, x greater than y. That too has a true or false answer, so we go one way or the other. But if x is 1 and y is 2, then no, the answer is false. 1 is not greater than y. So logically, in the flowchart, you follow the false arrow this time. And notice, along that false arrow, you don't print anything this time. That's why we only saw 1 print out on the screen. Now, there was still a third question here. Notice that no matter whether I go this program, and I think the behavior is going to be the same. Python of compare.py. What's x? Let's do 1. What's y? Let's do 2.
You're supposed to write elif. Okay. Elif. instead of else if.
X is less than Y. Now, honestly, I didn't really notice a difference when I ran the program, and honestly, my Mac, my PC, my phone nowadays are so darn fast that these kinds of improvements aren't going to necessarily feel any faster until we're writing bigger, faster programs, but it's laying the foundation for writing better code longer term. Now, what is the improvement I just made? Well, if previously my diagram looked like this, which was problematic insofar as I was asking 3 questions, no matter what, even if I already figure out what I want to print on the screen, this new version of the program that says if, elif, might look a little something like this instead. Now, it got a little wider. That's just because we drew the arrows to be a bit wider here, but let's focus on just how many questions are getting asked. Let me zoom in at the top as before, and let me propose that we note that the start oval is at the very top, and it's asking us to ask one question first. 2 is greater than 1. Well, let's go back to the diagram, same as before. We start at the very Python that allows us to be even better at expressing this logic, to design this program even better, and that's going to solve a particular problem. So if I take us back to our code here, notice that what I've highlighted earlier, elif x equals y, it's not wrong to ask that question. In fact, if you're trying to be especially thorough, it makes perfect sense to check if x is less than y, greater than y, or equal to y. But why don't I need to ask this third and final question?
We don't need to ask if x is equal to y anymore, because logically, if the 2 conditionals evaluate to false, there is only one conditional that will evaluate to true, and that is x is equal to y.
Exactly. If we're all pretty comfortable with math and comparisons here, of course, x is either going to be less than y, greater than y, or equal to y. But once you rule out the first 2 scenarios, logically, it's got to be the case that x must equal y. If it wasn't the case, that it's less than or greater than. So Hope proposed that we use this other keyword, else. And how do we use this? Well, exactly as we might in English. Let me go back to my code here, and instead of bothering to ask the third and final question, let's not ask a question at all. Let's just have this catch-all, so to speak, a final line of code that says else, just assume that x is equal to y, therefore printing it as well. So what's the upside of that? My code is still going to work exactly the same. And again, my computer's so darn fast, I don't even notice that it's working even faster than it was before. But we would notice these kinds of things if we were doing a lot more work, a lot bigger programs here. But let me run Python of compare.py. Let's do, for instance, 1 and 2. Still works for that. Let's do 2 and 1. Still works for that. Let's do 1 and 1. And it indeed now works for that. But in these cases now, let's consider the path we just went down. Previously, our diagram, when we had if, elif in place, looked a little something like this. And notice that, again, we might have asked 1 question, or 2, or worst case, 3 whole questions. But we can do better than that. Using else, as Hope proposed, we can whittle this diagram now down to this. And even though it looks like the diagram's getting bigger, notice that it's having fewer building blocks inside of it. There's fewer arrows, and there's fewer nodes in this picture. Let's start at the top now. Start leads us to the first question still. X less than y. If the answer is true, great. We can say as much, x is less than y, and we can stop. If it's not true, if it's false, we can ask the next question. X is greater than y, true or false? If it is, great. We can print x is greater than y and stop. Else, if it's not the case that x is greater than y, the answer is false, we can just immediately, logically say x is equal to y. We don't have to add the third question at all. We can just immediately conclude there. So what's the implication here? You can see with these pictures a relative decrease in the complexity of a program. The first one was very long and stringy with lots and lots of questions, unnecessarily ultimately. The next one got a little shorter, and this one's even shorter still. And again, the fewer lines of code you have, the less likely you are, arguably, to make any mistakes, the easier it is for other people to read. And so generally, this readability, this simplification, is indeed a good thing. Well, let's go ahead and add another piece of capability into Python, and that's this one here. Just like in English, where you can ask this question or this other question, you can say the same thing in Python using literally this word or. So let me go back to my Python code here, and let's propose how we might ask a couple of questions at once this time. Perhaps this time considering how we might ask not whether or not it's greater than or equal to and caring about the precise answer. Let's take a coarser approach here, and let's just try to determine is x equal to y or not. Well, let me go ahead and delete some of this code and change the question we're asking. Let me do this. Well, if I care about whether it's equal or not, let's check the possible scenarios. If x is less than y or x is greater than y, let's go ahead and print out x is not equal to y. Now, why is that? No pun intended. If x is less than y, well, it's obviously not equal. If x is greater than y, it's obviously not equal. So we can conclude x is not equal to y. So if we...
I'm just going to write a bit of code. VS Code. Okay. Else or operators, right? Okay. If x yes, then less than or equal less than 9 or equal to is greater than 9 and less than let's say 20. Print is in range. I think I'm supposed to say let's assign a boolean value, to x. X is equal to, let's say, I don't know, 10. Now let's run it. That's how you do it. There was something backslash n, right? Next line, right? Run. Yeah. And tab as well. Damn, this mouse is broken. I need to buy a new mouse. Okay, now what?
Instead, want to make sure that it is equal to, we can just use hopes else, using print, quote unquote, x is equal to y. And again, why is this? Well, if x is less than y or x is greater than y, they're obviously not equal. Otherwise, logically, they must be equal in fact. So let's run this. Let's go ahead and run python of compare.py. What's x? 1. What's y? 2. Okay, x is not equal to y. Let's do it again. But 2 for x, 1 for y, x is not equal to y. And one third time, about x is 1 and y is 1, x is now equal to y. Now, if we want to compare that visually to, let me propose that the picture looks a little something like this. And again, this is the exact same thing logically, but the pictorial representation thereof. What's the first question? Well, if x is less than y, well, then we follow the true arrow and we say, quote unquote, x is not equal to y, and then we stop. But what if x is not less than y? What if it's greater than y? What if it's 2 and 1 respectively? Then the answer to x less than y's first question is false, so we go here. We ask the second question because of the or, and that asks, is x greater than y? If so, notice this. We can kind of reuse some of the same parts of this picture and just say x is not equal to y. We don't need to add arrows and add boxes unnecessarily. We can reuse lines of code, parts of the picture just as we have lines of code, and then we stop. Lastly, we have the following. If we know that x is not less than y, we know that x is not greater than y, it must be the case that x equals y. We don't need to ask a third question, another diamond. We can just immediately print as much and then say stop as well. Well, what could I do here? I bet I can improve this code slightly. And if we really want to be nitpicky, I would argue that this is now really just a minor refinement, but it's a good habit to get into thinking about, could my code be better? Could my code be simpler? Could I improve this code further? It's subtle, but could I improve the design? Could I ask fewer questions? Could I tighten it up, so to speak? What do folks think?
You can ask if x is not equal to y. Then it will print x is equal to y, else x is not equal to y.
Perfect. Recall one of the other symbols we saw in the available list earlier. We can check not just less than or greater than or equal to. We can literally ask the question, is it not equal to? Why are we wasting time asking if it's less than or if it's greater than? Well, if all you care about is it not equal, I think we can do exactly that. Let's just ask the one simple question we do care about. And so let me go back up here and let me just say, not both of these questions. Let's get rid of the or. Let's just say if x is not equal to y, then go ahead and print x is not equal to y. And that too, I think is going to work exactly the same, but the picture now looks a little bit different. Notice that this was our flowchart earlier that represented that same logic, and there's a bit of complexity. You got to go left, you got to go right based on the answer to these couple of questions. If we now take into account what this version of the program looks like, it's even simpler. Perhaps the simplest one we've seen yet. When we start off the program, we ask just one and only one question: is x not equal to y? And if so, true, we go ahead and print out x not equal to y. If the answer is false, then of course it must be equal to y, so we say that instead. And if we really want, we could invert this. If I go back here to my code, and if for whatever reason you just prefer to think in terms of equal or not equal, as opposed to not equal or equal, it's really up to you. We could change this to be equals equals, but I'm going to have to change my print statements to be in the opposite order. So let me go ahead now and reverse these two here and move the second one first and the first one second. So now when I execute this code, I'm asking still just one question. So it's still just as good, just as succinct, but now the diagram, instead of looking like this, is going to change the not equal to equal equal, and we just need to make sure that we print out the right thing accordingly. And again, here too, just as the code is getting a little more compact with fewer and fewer characters, so are these diagrams, these flowcharts, capturing the relative simplification of each of those programs too. All right, let me go ahead and pause here to see if there's any questions now on any of these versions of code.
Yeah, I have a couple of questions. What if indentation is not used?
If indentation is not used, your program will not work. So Python is a little different from a lot of languages in that it enforces the indentation requirement. Some of you who have been programming for years might not necessarily be in the best habit of indenting your code properly, and one of the features, arguably, of Python is that it makes you indent your code or it will not just work. And I think, did you have one other question?
Is the colon necessary?
Is the colon necessary? Yes, the colon too is necessary. So with Python, what you see is what you get here, and indeed it needs to be indented, and the colon is necessary. Python does not use in the same way by convention as C and C++ and Java curly braces to connote blocks. Instead, it relies indeed on this indentation. Well, let me propose that we introduce one other keyword here in Python to see exactly how we might combine additional thoughts, and that's going to be literally the word and, a conjunction of one or two or more questions that we might want to ask at once. And let me propose 70. I'm going to go ahead and give them a D, and here's where it's a little anomalous, at least in some schools here. Else, I'm going to...
This was like one of the the first assignment where I used else if statement when I was doing C++ and my programming fundamentals course.
Just like you could do on paper pencil if you really wanted. But now notice this trick, and this is not possible for those of you who have programmed in C or C++ or Java or other languages. Notice what I can do here is actually combine these ranges. Notice that I'm asking two questions, two Boolean expressions. Is 90 less than or equal to score, and is score less than or equal to 100? Well, Python allows you to nest these things like this and chain them together. And just like you would on paper pencil in the real world, you can in code in Python do this, which is just a little cleaner. Right? It's tightening up the code a little bit. It's fewer keystrokes. It's faster to type. It's easier to read moving forward. So that's arguably better as well. So that's one improvement. It's largely aesthetic in this case. It's still asking the same number of questions, but it's doing it a little more succinctly still. Well, what more could I do here next? Well, you know what? Each time I'm deciding these grades, I don't think I have to ask two questions. I don't have to ask, is it greater than 90 and less than 100? Is it greater than 80 and less than 90? If I kind of rethink my logic, I can maybe do this better still. Let me propose that we simplify this further and just do this. If we know the input for the moment is going to be within 0 and 100, we can make some assumptions. We could say something like, if the score is greater than or equal to 90, well, the student gets an A. L if the score is greater than or equal to 80, the student gets a B. L if score is greater than or equal to 70, they get a C. L if the score is greater than or equal to 60, they get a D. Else, they get an F. So what have I done here? Well, instead of asking two questions every time, checking the lower bound and the upper bound of that range, I'm kind of being a little more clever here by asking if the score is greater than 90, well, they've obviously gotten an A or better. If your score is greater than 80, well, you either deserve an A if it's really strong, or a B if it's just above 80. But because of the if logic, we've already checked, is the student's score greater than 90? And if it's not, then we're asking the question, well, is it greater than 80? So you implicitly know it's somewhere in the 80 to 89 range. Else, you know it's in the 70 to 79 range. Else, it's in the next range down. So it's a minor optimization that allows us to ask fewer questions, but again, it's making the code arguably a little more readable, certainly more succinct, and then hopefully more maintainable longer term. Any questions then on these types of changes and this type of logic with our code?
What if we don't use elif at all? What if we write the code in F?
Yeah, so that's a good question because it's actually going to have an unintended effect here. Let me get rid of the F temporarily and just focus on A through D. If we revert to where we began today's story with conditional, saying if, now our cleverness here of using broader strokes and not using an upper and lower bound ranges is going to come back to be a downside. Let me go ahead and run Python grade.py, and suppose my score is 95. I am so darn excited. I want my A, but nope, I just got an A, a B, a C, and a D. So logically, that's broken things, because if you don't make these conditions mutually exclusive, every one of those questions is going to get asked and therefore answered. And even if your grade is above a 90, it's also logically above an 80, above a 70, above a 60. And if I kept it in there, I would have failed as well with an F. Really good question. Other questions here on this form of logic?
Like, would there be any, better way to kind of clean up even just this simple statement like you had before, the previous one you had with the else if?
Oh, I like your enthusiasm for simplifying things further. I'm going to go out on a limb here and say this is about as good as it gets, at least using only conditional statements. I can, if my mind wanders, think of a slightly more clever way to do this, maybe with something called a loop or another programming construct. We don't have that yet in our vocabulary, but yes, there's absolutely other ways to do it, but I think not yet if we want to restrict ourselves to just words like if and or and else and elif and the like. Well, let me propose that we pivot now to use another approach here that uses one other symbol that up until now we've not really had occasion to use. Let me propose that we implement a program that we'll call parity. In mathematics, parity can refer to whether a number is even or odd. And that's kind of an interesting question, and it turns out it can be useful in other applications too. So I just ask the question, is a given number even or odd? Maybe that the user typed in. And let me go ahead and write a new program called parity.py via code parity.py in my terminal. And let me propose that we use this as an opportunity to introduce the last of those arithmetic symbols, at least most of which we're familiar with: addition, subtraction, multiplication, division. But there's been on this list before this last one here, a percent sign. And it doesn't mean percentage in this case when used as an operator in programming in Python. Rather, it represents the so-called modulo operator for modular arithmetic, or at least in our case, we're going to use it to calculate the remainder when dividing one number by another. Well, what do I mean by that? Well, if you take a number like
mod, I totally forgot about mod.
1 divided by 3. 3 does not go into 1 cleanly, so you have a remainder of 1. 2 divided by 3 has a remainder.
Yeah, the remainder thing. I'm going to go for a while, a little bit.
remainder of 2. 3 divided by 3 has a remainder of 0 because it divides cleanly. 4 divided by 3 has a remainder of 1 because you can divide it in once, but then that leaves 1, so it has a remainder of 1. And then lastly, something like 5 divided by 3 has a remainder, of course, of 2. So that's all we mean by remainder, how much is left over after dividing one number by another. Well, if I go back now to my code and I consider how I might implement the question, is this number even or odd? Let's consider how we might implement that. Since it's perhaps not necessarily obvious how we can use this additional building block, but it turns out it's going to be very useful longer term. Well, let's first just get a number from the user in a variable called x, and I'm going to set that equal to the conversion to int of whatever the user inputs after asking them what's x question mark. And we've done that before many times. How do I now determine if x is even or odd? Well, it turns out if I have access to a programmatic operator that tells me the remainder, I think I can do this. In fact, let me just ask the group, and this is just from grade school math perhaps, what does it mean for a number to be even? To be clear. A number like 0, 2, 4, 6, 8, 10, 12, 14, 16, those are all even numbers, but what does that really mean? Elena, if I'm saying that right?
Even numbers that can divide it exactly by 2. For example, 2, 4, 6, 8, and 10. And
Perfect. So we could go on all day long, literally. So there's an infinite number of those even numbers, but it's nice that you formulated it in terms of a question that we can ask very clearly. Is this number cleanly divided by 2? That is, can we divide it by 2 with no remainder, a remainder of 0? Well, that's perfect, because if we have this operator, this percent sign, that allows us to answer just that. What is the remainder? We can presumably check, is the remainder 0, or is it 1? Do we have nothing left over, or do we have 1 left over? Well, let's ask that. If x divided by 2 has a remainder of 0, as Elena proposes, let's go ahead and print out something like quote-unquote even, and just say as much to the user. Else, I think we can assume that if a number is not even, it's going to be odd if it's indeed an integer, so I'm going to go ahead and print out quote-unquote odd instead. And let's go ahead and now run python of parity.py in my prompt. What's x? Let's start with 2. 2 is in fact even. Let's start with 4. 4 is in fact even. Let's get interesting with 3. 3 is now odd. And I think we can do that all day long and hopefully get back indeed exactly that answer. But what more could we do here? How could we improve upon this? Well, recall that we have the ability to invent our own functions. And let me just propose for the sake of discussion that we're going to eventually find that it's useful to be able to determine if a number is even or odd. And so we'd like to have that functionality built in. And I don't think Python has a function for telling me just that, but I can invent it using code like just this. So let me go into my earlier version here, and let me propose that we do this. Let me go ahead and write a main function. I'm going to get back into that habit of defining a main function to represent the main part of my program, and I'm going to do what I did before. I'm going to get an integer from the user's input, asking them what's x, question mark, and then I'm going to ask this question. For the moment, I'm going to naively assume that the function already exists, but that's a useful problem-solving technique. Even if I have no idea yet where I'm going with this, how I'm going to invent a function that determines if a number is even, I'm just going to assume that there's a function called isEven, and I'm going to call it blindly like this. If isEven, passing in x, then go ahead and print quote-unquote even. So if this magical function called isEven returns true as its return value, I'm going to print out that it's even. Else, otherwise, I'm going to assume that it's, of course, odd. Now, the one problem with this program, even if I call main over here, is that isEven does not exist, and this program would break if I ran it right now. But that's okay. I have the ability, recall, to invent my own function, so let me define with def a function called isEven. I want this function to take an argument, and I'm going to call it n, just a number, generically. I could call it x, but again, I don't want to confuse myself as to which x is which, so I'm going to give it a different name, and that's fine. I'm just going to call it more generically n for number. And then I'm going to do this. I'm going to say if n%2 equals 0, just like before, then, and here's the magic, you, the programmer, can actually return what are called Boolean values. We've seen in Python that Python has strs or strings, ints or integers, floats or floating point values, all of which are different types of data in Python. Python also has a fourth data type called bool for a Boolean value. And even though this is just adding to our list, the nice thing about bools is that they can only be true or false. An int can be any number of infinite possible values. A bool can only be true or false. And it must be capital T and capital F if you're writing itself. So if I go back now to my code and I consider exactly what I want to return here, well, if n%2 equals 0, that is, if n divided by 2 has a remainder of 0, well, I think it's even to, Elena, your definition, so let's return true, capital T. Else, if it doesn't have a remainder of 0, I'm pretty sure mathematically it's got to have a remainder of 1, but it doesn't matter. I know it's not even, so I'm going to return false. And we return false instead, capital F. And now that we've defined both main and isEven, and I'm calling main at the bottom, I think I've got this right. Python of parity.py, enter. What's x? Let's try something simple like 2. And it's even. Let's do it again. What's x? How about 4? Even. Once more. What's x? How about 3? And it's odd. Now, what have I done here? I've just made the point that if I want to create my own function called isEven that answers this...
Exactly. Let's define a main function. Clear. Dot py. Like let's say I trust which entitled this. Okay, let's define a main function. Main function. And in this main function, I'm gonna do what? Boolean expressions. We're gonna use Boolean. Yeah. Forgot to do the colon thing. I hate this keyboard. It's good for gaming, but man, this layout is not good for me. writing code. Okay. If is even equal true. What was the code like?
This question for me that I can now use in this program and heck, maybe future programs that I write. I now have a function that no one gave me. I gave myself that I can use and reuse. I can even perhaps share it with others. I'm using that function now on line 3 just to make a decision. I'm using
Oh. Okay, I get it. If true, let's give it a number. It's gonna be x. Print else why the hell isn't the key working? Print is odd. Now let's x equal int input give number. Now let's make that is define is the function. Did I write an underscore? Okay, I needed to write an underscore. I almost forgot to do that. Can you guys even see what I'm doing? It's not like anyone's here. If function, let's define it as I. It's a good practice. Let's now use Boolean expressions. I is where is the percentage sign? was not supposed to write X. Now run the code again. This mouse, this bloody ass mouse. Ah. This bloody mouse. Let's rerun it. Which file is it even running? Wrong file. Let's say 4 is an even. One is an odd number. Is odd. Well, okay. What is this? Copilot.
A conditional up there, and my Boolean expression, something that's true or false, is going to be not something explicit like x less than y or y greater than x or the like. It's going to be a function call. I'm using a function as my Boolean expression, but that's okay because I know, because I wrote it, that that function is even, returns true, or it returns false. And that's all I need in a conditional to make a decision to print even or print odd. So let me pause here to see if there's any questions now on how I've implemented is even using this bool.
Hello, hi David. First of all, thank you for this wonderful class for yesterday and today, sir. I have just one query, like based on the background of Java. There, when we used to pass the arguments, we can also pass the address of the variables. So is there any sort of this concept in Python?
Short answer, no. Those who are unfamiliar with Java or other languages, or C or C++, there's generally ways to pass values in different mechanisms that allow you or disallow you to change them. In Python, no. Everything we're going to see is actually, in fact, an object, but more on that down the line. How about time for one more question here on these bools and these is-evens?
So I actually had a question about defining a function, if that's okay. Sure. So if you define one, are you, like within your code, like you made it up, are you allowed to use the dot operator like we did name dot strip and use it like that?
Good question. If you've created your own function, can you use other functions like .strip or .title or .capitalize that we've seen in the past? You can use those on strings. Those functions come with strings. You can't necessarily use them on your own functions unless your function returns a string, for the examples you gave. I'm returning a bool. Bools have no notion of white space to the left or the right. You can't call strip, you can't call capitalize. But if you were writing a different function that returns a string, absolutely, you could use those functions as well. Well, let me turn our attention, if I may, back to this example here and consider, as we now frequently do, can we improve on the design of this code? Can I make this particular program better? And I can. There's a couple of ways here, and I'll show you something that's now generally known as something Pythonic. There's actually this term of art in the Python world where something is Pythonic if it's just the way you do things in Python. Which is to say, we've seen already there's so many different ways to solve certain problems, and in the Python community of programmers, there tend to be some ways that are smiled upon more than others, and they tend to relate to features that maybe only Python has, but not other languages. And here's some syntax that you might not have seen in languages like Java or C or C++. If you've programmed before, and if you've never programmed before, this too is going to be new. Instead of asking a question like this, if, else, using 4 lines, in Python, you can actually collapse this into just one more elegant line, if you will. Instead of asking, if n divided by 2 has a remainder of 0, return true, else return false, let me delete all of that and just say this, return true, if n divided by 2 has a remainder of 0, else return false. Now, those of you who do have prior programming experience might actually think this is kind of cool. You can condense from 4 lines into 1 line that very same thought. And one of the reasons why Python is popular is that it does tend to read rather like English. It's not quite as user-friendly as most English or most human languages, but notice now, the line does rather say what you mean. Return true if n divided by 2 has a remainder of 0, else false. I mean, that's pretty darn close to something you might say logically in English, be it about even and odd or really anything else. So that program's going to work exactly the same. Python of parity.py, let me type in 2, it's still even. Let me type in 3, it's still odd. But I can refine this even further. And again, consistent with this idea of not just writing correct code, but writing better and better code, but still keeping it readable, I can do one even better than this. Notice this value here is my Boolean expression, and it is going to evaluate to true or false. Is n divided by 2 having a remainder of 0 or not? Like, that is by definition a Boolean expression. It has a yes-no answer, a true-false answer. Well, if your Boolean expression itself has a true or false answer, why are you asking a question in the first place? Why ask if? Why say else? Just return the value of your own Boolean expression. And perhaps the tightest version, the most succinct, and still readable version of this code would be to delete this whole line, Pythonico it is, and just return n modulo 2 equals 0. If it helps, let me add parentheses temporarily, because what's going to happen in parentheses will happen first. N divided by 2 either does or does not have a remainder of 0. If it does, the answer is true. If it doesn't, the answer is false. So just return the question, if you will. You don't need to wrap it explicitly with an if and an else. And in fact, because of order of operations, you don't even need the parentheses. So now this is perhaps the most elegant way to implement the same idea. Now, which is better? This is pretty darn good, and it's hard to take fault with this because it's so very succinct, but it's...
I have a question. So, okay, the output value is in Boolean expressions in Python. I have to study that a little bit.
It's perfectly okay and just as correct to have an if and then an else, even though it might be 4 total lines, if that helps you think about your code more clearly and it helps other people reason about it as well. So it turns out there's another syntax that you can use to implement the same idea of a conditional, whereby you do something optionally based on the answer to some Boolean expression. And the keyword that you can now use in recent versions of Python is called this, match. Match is a mechanism that, if you programmed before, is similar in spirit to something called switch in other languages. For instance, let me go ahead here and close out parity.py, and let me go ahead and create a new file called house.py. And in house.py, I think what we're going to do is try to implement a program that prompts the user for their name and then just outputs what house they're known to be in the world of Harry Potter. So for instance, let me go ahead and do this. Let me give myself a variable called name, set it equal to the return value of the input function, and I'll say something like, what's your name, question mark. And then after that, I'm just going to use a traditional if else construct to decide what house this person is in. So let me say if name equals, say Harry, as in Harry Potter, well, let's go ahead and print out Harry's house, which is Gryffindor in the world of Harry Potter. If the name is instead Hermione, then go ahead and print out also, quote unquote, Gryffindor, as she's in the same house too. If name equals Ron, let's go ahead and similarly print out Gryffindor, quote unquote. And let's make this a little more interesting now. If name equals, quote unquote, about Draco Malfoy in the books, let's go ahead and print out, quote unquote, Slytherin. And just in case someone else's name gets inputted for now, let's just suppose that we don't recognize them and say, by default, else print out, quote unquote, who, question mark, just to convey that we don't actually have a hard-coded response to that particular name. Let me go ahead now and run this as Python of house.py, enter, and I'll go ahead and type in something like Harry. And while we see that Harry is indeed in Gryffindor, let's run it one more time, Python of house.py, let's type in Draco this time, Slytherin, and now let's type in an unrecognized name. Let's go ahead and rerun Python of house.py, and let's go ahead and type in Padma, enter, and who, because we haven't actually hard-coded with an elif condition in this case, what house Padma is meant to be in. All right, well, it turns out there's other ways to implement this. Indeed, there's some redundancy here in that we're checking if Harry or Hermione or Ron are all in Gryffindor. I feel like we can at least tighten this code up a little bit using techniques we've seen already. So let me go ahead and do this. Let me go up here and instead do something like this. Let's get rid of these two blocks of elifs, leaving just Harry's for a moment, and let's use that or keyword again and say or name equals, quote unquote, Hermione, or name equals, quote unquote, Ron, thereby consolidating all three cases, if you will, into just one if statement. Then we still have a separate elif for Draco because he's not in fact in Gryffindor, and then the final else to catch anyone else. All right, let me go ahead now and run this version of the program, Python of house.py. I'll type in Hermione this time. She too is still in Gryffindor. Let me try it with Ron, and that too still seems to be correct. Well, it turns out there's another approach altogether that can perhaps make your code a little less verbose. You can imagine how complicated this code might get if we had not just Harry and Hermione and Ron, but a whole bunch of other names as well for Gryffindor, for Slytherin, and for all of the other Hogwarts houses. So you can imagine that code just getting pretty unwieldy pretty fast. Well, it turns out another technique you can use is indeed this keyword called match, which is very similar in spirit, but the syntax is different and allows you to express the same ideas a little more compactly. So let me go back to house.py and let me propose that I get rid of my current if else approach and instead do this. Literally use the keyword match and type the name of the variable or value that we want to match on, and then I'm going to go ahead and include a colon, and then underneath that I'm going to include literally a keyword called case. And the first case I want to consider is going to be Harry, and I'm going to put Harry in quotes because it's a string or a stir, and I'm going to have another colon at the end of this line, and indent under that one I'm going to go ahead and for now print out Gryffindor, which of course is Harry's house. Otherwise I'm going to have another case for quote unquote Hermione, and similarly I'm going to have under that indented print quote unquote Gryffindor, close quotes. Now I'm going to have another case for Ron, also in quotes with a colon, now print quote unquote Gryffindor, and now I'm going to have another case for, let's say, Draco. This one gets a little more interesting because Draco of course now is in Slytherin, and then I'm going to go ahead and leave it as that for now. So let me go ahead and save this file and go back down to my terminal window running Python of house.py, enter, and let's go ahead and try Harry, and he seems still to be in Gryffindor. Let's run it again for Hermione, enter, Gryffindor. Let's skip ahead to Draco and type in Draco's name. He's indeed in Slytherin. Now let's try another name that we haven't handled a case for, like Padma again, enter, and we're just ignored. There's no output whatsoever because there wasn't a case for Padma. Now we could of course go back in and explicitly add one for Padma, but what if we similarly to the else construct just want kind of a catch-all that handles anyone whose name is not explicitly specified? Well, it turns out the syntax for that using this new match statement is to still have another case, but then to use this single underscore character, which is used in other contexts in Python, but for here it's meant to say whatever case has not yet been handled, go ahead and print out as we did before, for instance, quote unquote who with a question mark at the end. Now let's go ahead and rerun this Python of house.py. I'll type Padma's name again, and this time I think we're at least going to get an explicit response indicating who, whereas previously we did not have the equivalent of that. Now I think we've regressed a little bit. We went from tightening things up by putting Harry and Hermione and Ron all in the same line in the same if statement, but here we have now three case statements again for all three of those. Well, we can tighten this code up as well, but the syntax is going to be a little bit different. I'm going to go ahead and delete these two middle cases for Hermione and Ron, and then up here next to Harry's name before the colon, I'm going to go ahead and use a single vertical bar and then a quote unquote Hermione, then another single bar and do quote unquote Ron. And this is how, using this relatively new match statement, you can say the equivalent of Harry or Hermione or Ron, but more concisely than you could using an if statement alone as we implemented it previously. So now one final run of the program with Python of house.py. Let's make sure that Harry's still in Gryffindor. Let's make sure that Hermione's still in Gryffindor. Let's make sure that Ron is still in Gryffindor, and indeed all three of them are. Now, as always with Python and programming more generally, there's going to be different ways you can solve these problems. This is just another tool in your toolkit. Arguably it has tightened things up. Arguably it's perhaps a little more readable because there's a little less syntax going on, a little less duplication of equal signs and elif and elif and elif all over the place. But ultimately this would be an equally correct approach to that same problem. But it turns out with the match statement you can do even more powerful forms of matching as well. Here we've used it simply to implement the same idea as that if, elif, else construct. And it's worth noting, if you've programmed in some other language, the syntax here is indeed correct. You do not need, for instance, a break statement as has been peppered throughout, and you don't need something like default or something explicit. You indeed just use this underscore as your catch-all at the end of the match. So just by adding in some of these new keywords here, like if and elif and else, we have now the ability to ask questions about values. We have the ability to analyze input from users and ultimately make decisions about it. And these then were our conditionals. Lying ahead is going to be the ability for us to not only use functions and variables and also use conditionals, but also next loops, the ability to do something now again and again.
Next. next? There's probably some like. Yeah, I don't need these. Loops. I guess that's it for today, guys. See you in the next one. Peace out, I guess. Today's stream was alright, I guess. I'm kinda tired for some odd reason. See you later.